we're back at it again. So I already did the Monopoly video on basic probability theory and conditional probabilities. Now we're going to do it in Hearthstone. Okay? So this is Hearthstone, it's a card game, but this setup is almost exactly like the one we looked at in Monopoly. The outcomes are the same. We have two possible outcomes. This time we are going to try and throw out some arcane missiles and see if it kills this totem or not, if they all hit the face. So I'll kind of talk you through the setup, but the probabilities are extremely similar. They're slightly different, but pretty much the same. So what's going to happen is this card shoots 3 damage randomly split among all enemies. So right now the only minion on board for my enemy is this Wrath of Air totem, and it has 1 health. So if it hits it 1 time, it dies. If it misses it, it's going to hit the shaman in the face. So there's only one way for us to have 3 missiles go out here without killing this totem. So assuming my goal is to kill the totem when I throw the card, then our probabilities break down very similarly to the one that the Monopoly had. So let's talk through this real quick. So the first missile, assuming they all behave the same, so we have 3 separate ones, they all behave independently. The first one's going to go out, 50% of the time it's going to hit here, 50% of the time it's going to hit here and kill this. Okay? If it does not, then the next one will be the same, 50% and 50%. And if it does not, then again 50% and 50%. And each time the conditional probability of killing the totem will go down. Now a lot of people see this particular situation, and I've seen people in similar situations say, well, we have a 67% chance of hitting the totem, and that's not quite correct. So let's talk about the only way we miss the totem. So to miss the totem completely, we'd have to hit the shaman 3 times in a row. The probability each time would be 50%. So 0.5 times 0.5 times 0.5, which is 0.5 times 0.5 is 0.25 times 0.5 is 0.125. So 12.5% of the time we will miss the totem entirely, which means that 87.5% of the time we will kill the totem and do 2 damage to the shaman. So that's our most likely outcome. But if we miss with the first missile, so if the first one goes face, now we only have 2 chances to hit this. Okay, so now we have to miss completely, it'd be 0.5 times 0.5. So now 25% of the time we'll hit face both times. So conditioned on missing the first missile, our probability goes from 87.5% to kill this down to 75. And then of course if the first 2 missiles both go to the shaman's face, then we only have a 50% chance of the last one hitting the totem and killing it like we want to. Okay, so very similar to the structure that we had on Monopoly. Let's go ahead and throw this and see what happens. Alright, here we go. My computer has enough. 1, 2, 3. The first one hits face, last one hits the totem, and we get the result we want. So hopefully the animation comes through. I know my computer is not the most powerful thing in the world, but once you kind of understand what I'm talking about with this and with Monopoly, what we can do is we can start thinking about other games. So what does this look like in poker? And I can set up situations like that. What does this look like in baseball? I can set up situations like that. And then hopefully eventually we can start talking about how this looks in real life situations. So we can come up with a bunch of business or school or other types of situations where we can talk through probabilities of occurrence of an outcome we want to happen, basically, and trying to say how many shots we have at that particular thing. So this is a basic probability theory problem, and you see that the conditionality is from when we have repeated attempts. So this time we had 3 missile attempts. The other one we had 3 roll attempts. But you could have any number of attempts, 2 on up, basically, and they always behave this way if each one is independent. Alright, that's all I got for you this time. We'll talk more about probability theory on another day.